Future of Building with BIM, which would be conducted by Mr. Brent Morty, Principal Architect, CH2M Hill. Mr. Brent is a practicing architect in Canada and acts as a CH2M Hill's global BIM leader within their water market. He has devoted his career to the interoperable deployment of BIM across CH2M Hill's global offices. He focuses on harnessing data throughout the life cycle of projects and programs. He has 10 years of design and construction experience, focusing on industrial and government facilities, along with residential and light commercial segment. Brent has worked on the London 2012 Olympics, the Panama Canal widening program, and Abu Dhabi's Masdar City, amongst other projects large and small. Thank you.
Thank you very much, everybody. So I'm going to talk about building information modeling and the approach that CH2M Hill has taken with respect to how we globally deploy the process, as described by Malcolm previously, in order to obtain a robust approach with respect to understanding and delivering the concepts. But first off, we look at BIM as a set of processes, but described more as a cookbook. And this concept of a cookbook has helped us to look at all of the vast possibilities that exist when it comes to building information modeling and applying that throughout our firm. So if you think of a cookbook contains various recipes containing various ingredients, and we then want to select the correct recipe to meet the client's or project's needs and to apply that globally throughout our infrastructure. Some recipes are different. Some are easy, efficient, quick to realization. Others take some prep time. Others have a different way to assemble. But at the end of the day, it's that ability to understand the information and apply it. So here are some of the ingredients. And when we look at these ingredients, when people ask, do you know what BIM is? And there's always that person in the audience who puts up their hand and say, oh, it's Revit, oh, it's something else like that. Revit is a piece of BIM. It's one of the ingredients that could be used. These are all of the platforms that CH2M Hill currently stewards within our various markets. I sit currently as the global leader within our water market, and I function as steward for our building and plant applications. But you could see, spanning our various markets, we have all of these tools that could be used as an ingredient for a BIM recipe on a project. We then have these other tools, other ingredients, that we don't normally steward within CH2M Hill, yet due to client requirements, they may be brought forth. So for example, 12D down in Australia, we'll be doing a project, a client says we must do that for civil. That's no choice, that's what we have to do. We have some industrial water clients within the Middle East that have driven us to use the Aviva product. Great product, it's focused on plant design, and we integrate that with the other systems that we have at play. We had a client in the United States that actually wanted a Graphisoft turnover of all of our building and plant models. So that was an intriguing challenge, using industry foundation classes to export geometry and information from our Bentley models into the Graphisoft world. There were some successes and some not so much successes, but we were able to work through it. And then finally, we have the platform. And these platform tools are, for me, the backbone upon which information modeling resides. So when you look at AutoCAD and MicroStation, ProjectWise, that term CMAS, that's an internal procurement system that CH2M Hill has developed so that when we have information models of components like valves, we can extract that information and harness the information across multiple projects in order to procure for design build type projects. Notice the big purple circle there. So we've got SharePoint, Primavera products, Aconex, various other types of server-based systems, all used as part of the program lifecycle. So not just projects, but programs, in order to manage information across the lifecycle of a project, like the London Olympics or the Panama Canal widening, where information starts somewhere else, is fed into the BIM process, then goes somewhere else, and you want to ensure that there is that connectivity throughout that information's lifecycle. But I want to stress that CAD portion, the CAD stream going vertical. If you're in the situation where you're talking about layers and pen weights and all of those wonderful things that were of critical importance 20 years ago, we want to move beyond that now. Those don't drive BIM. So when we're using any of our BIM tools and we're trying to create drawings and representations, that's the last thing we want to talk about. So we use the national CAD standards founded in the United States and adopted in other countries like Singapore, Australia, and even the United Kingdom, where we're able to just harness simple layers and line weights and pen tables, so we never really have to talk about that stuff again. Very critical for pushing BIM, in my opinion. So then there's many more ingredients or influences. So this diagram here was my ability to represent to my internal management what is BIM. So we have the definition, and the definition makes perfect sense. But when you think about, well, are we doing BIM? So I divided it into these 4 buckets. And I have a very strong line dividing what's on the left and what's on the right. And unfortunately, I drown on the technical side of BIM. And that technical side involves developing and delivering training, coordinating the output with CAD, coordinating across the enterprise with respect to what we're doing and why we're doing it, configuring all of those various tools. So all of those buckets that we steward, whether it's Autodesk, Bentley, or Intergraph products, they have to be configured and tested and deployed and upgraded and interoperable. It's a never-ending job. Operational coordination, for me, that's a very critical piece that I think gets lost in the BIM world. So once you have all the tools working, you still need management support. You need the ability to steward people. You want to have people to champion the process. You want people to grow their own careers so that you're not trying to push a stone up a hill, but you have a well-oiled ship that's actually functioning properly. All of that, I would argue, is 1 or 2 or 3 full-time jobs, but the crux of BIM is on the left. So we've spent years focusing on design BIM, harnessing what we're doing and why with respect to our various design disciplines. So within CH2M Hill, we've got your typical architectural, structural, civil, building mechanical, electrical. We have process mechanical and piping, and we have some other specialty ones like instrumentation and controls. Then on the life cycle side of BIM, it's harnessing and stewarding information beyond design into construction operations, through design build projects to document and project controls. And then selling BIM, we do a lot of work submitting for Bentley Awards, events like this where we're portraying our capabilities. Now I'm not going to go in, I'm going to press the button here. This is everything. Then it goes on and on. Every single one of these bubbles have tasks and missions and never-ending needs that need to be addressed. For me, this is the BIM world within CH2M Hill. This is what I steward, and it's very complex. Now, if you've never done BIM, you look at this and think, well, how could we possibly do this? And you can. It all starts one step at a time, growing into what I describe as what's inside my brain today. But a simple recipe, so you're baking a pie. This is the pie chart of what I believe will be a successful recipe for BIM. This is not listing any particulars, but it's taking all of those requirements and showing them as equal sixths. That term project automation lead, that's our internal term for a project-specific BIM leader. And I think that's a heavily critical piece that as we grow across the globe, that concept of somebody at the project level who is accountable for BIM, for building the recipe. What tools are we using? What BIM goals are we trying to achieve? How are we going to do it? Why are we doing it? What does the client want? How do we meet the client's needs? All of those questions have to be entertained and answered and a BIM execution plan developed, and then that individual held accountable for deployment and managing and quality checking what's happening with respect to BIM. Everything else around this pie here are just pieces of that entire picture. If all of these can be addressed, then you have a successful recipe for BIM. But if we go back to the basics, BIM is essentially some geometry plus information, giving it parametric value, and that information can then be fed and harnessed and expanded throughout the life cycle of any one single component. And I'm going to talk more about that in a bit. But oftentimes you've got to look at BIM and break it down to that component level, because there are some components that I will term as an asset of importance. So those are the components that will be expanded upon throughout the life cycle of a project. And there are other components that are just components. And my favorite example is the carpet. You guys, all your feet are on this carpet. Once the carpet is modeled and it's identified as carpet, what more will be required throughout its life cycle? And think about that versus an air handling unit inside a building or a valve inside a treatment plant. These types of components that will require operational attention and require cost throughout their life cycle. So it's a different mode of delivery. If you've done this, you're now doing this. So the drawing comes from the model. This was a project I worked on back in 2003. So you can see the intensity of it. When I talk buildings, it's not just the traditional architectural building. It's the all-encompassing multidiscipline building. And I will stress that it includes the extensive piping networks that may reside within the building when you're on plant projects. And that's an interesting challenge when it comes to building that right BIM recipe, because that piping network has very specific types of tools and processes. Another example, taking that model to realization on site. So when we started doing BIM a decade and a half or so ago, it was a lot of examples of all these models and visualizations. Now with projects coming to fruition, we can actually do those side by sides and compare how good was our model through design and construction relative to what was actually built on site. And it's pretty impressive when you do those side by sides. So when we look at this wheel of BIM, this is what drives our BIM execution plan. If you've never seen an execution plan, you can Google Penn State University, and they actually have what seems to have been being adopted as an industry standard for an execution plan. It essentially defines all of the goals around the wheel as what you would try to achieve on a project. In CH2M Hill, if you go down that center column, any project, whether it's building, civil, or plant-based, has those aspects. We start with a model, we produce drawings and schedules, and we do some type of design and constructability review. That's that visualization piece, level 1 BIM. You get into the model, you can drive it around like you would any gaming application, see, experience, and understand what's happening. And the beauty of that is you could do that right at 10% of your design. Right when the design starts, when the first slab is put in place, the first component, you can visualize it and understand it. I'm not going to go through all of these, but the two on the top right, for me, analysis and operations management, are two huge pieces. So analysis, from the perspective of design BIM, we've been doing this for years and years, but we're still somewhat weak on the full interoperable abilities that you can achieve when it comes to analyzing your model. So there are several third-party tools, several analytical tools housed within native BIM applications. So whether I'm using Bentley's EcoSim, it has EcoSim Energy Simulator as a complement. If I'm using Revit, there's various third-party add-ons to Revit, and then there's various external tools. So you use something like a GBXML export from any building application to go into energy analytical type tools. I can get into structural analysis tools where Bentley has the integrated structural modeler workflow, where I can actually go from Revit or Bentley into what's called an ISM model, and then into the structural analytical programs. We can do pipe stress analyses on our pipes. Now this I mentioned earlier in that picture. When we have buildings that contain pipes, it's very critical to understand the difference between a building application and a plant application. And I have a slide talking about that in a bit. But only certain applications can feed pipe stress analysis tools, whereas building applications really cannot. Operations and asset management. For me, this is probably the heaviest one that's coming to fruition. The survey that Malcolm showed was talking about more BIM awareness, and there was one about owners. I think the numbers now are like 50 saying that they are BIM aware or have some type of BIM requirement. Now, it's those owners with a robust BIM requirement that are driving us to understand that there is an asset management requirement. They know we do BIM. or they expect that we and our competitors are doing BIM. And thus, they're not going to prescribe how we do it, but they want an output. If it's a water treatment plant, they want to know about their valves. They want to know about their pumps. They probably want to know about their pipelines. They have specific elements of information that they want extracted out of the model, and they want that information to feed whatever their asset management system is, whether it's Bentley AssetWise, Maximo, or some other homegrown custom system. They want the information, and that's part of the BIM requirement. Scheduling and programming comes up a lot. This is the 4D simulation, the ability to visualize a model, not only with respect to the components, but to actually see how the components will grow over the timeline of a schedule brought into the model from other tools like P6 or Microsoft Project. So this concept here, we developed this slide on the London Olympics, and this was initially thought of, you have those elements of BIM throughout design, and then you can take that same model and do various other things to the model during construction, like develop work packaging, 4D simulation, sequencing, and the creation of as-built modeling. You can take that same information into operations, and you can then feed maintenance-type information onto various components that are assets of importance. And then on the Olympics, there was an important concept of data to the very end. So if we're designing and constructing, for example, the Olympic Stadium, it was an 80,000-seat stadium to become a 30,000-seat stadium. So that decommissioning concept of what happens to all of that material and component post the fit for purpose, and where does it go, and what is eventually to become of those facilities. So that was the concept when we made this slide. And then when we were looking to apply this globally, I'll go back to the carpet versus the pumps. So the carpet, once I model it in design, I know what the carpet is, I know all of its properties, I know its area. During construction, I'm not sure what I'd add to it. Maybe a link to the product information sheet. That's probably it. But the pump components or valve components or air handling units, hospital laboratory equipment, stuff like that would actually follow that complete supply chain. So that information will grow throughout the life cycle of the project as you might want to procure, you might tender various manufacturers. Once the right one is procured, the model geometric information might change. The tagged information might get updated. It might have to be linked to an asset management system. And then the maintenance and operational data will either be added to the component or linked from the component to the actual repository. So a lot can happen to these specific assets of importance, which again are very different from that of the carpet, which probably resides just in design. So a little bit on connectivity, and I'll try to be sensitive to time here. The common data environment is a major requirement in the BS 1192 in the UK, and for us it's one of those backbone pieces with respect to how we deploy BIM. So we use ProjectWise globally, and it's our ability to actually manage the developed content throughout the project's life cycle to connect our various offices and connect our external teams as well. Critical for us is also that preservation. So when we build something, being an architect by trade, if I make a door once, I don't want to make it more than once. I want to be able to harness that information and further it regardless of what my authoring tool is. So this is our ProjectWise infrastructure, a quick diagram of it. The heart of it is the purple, the corporate data center. We have data centers that currently housed in Buenos Aires, Sao Paulo, Denver, and London, and they all provide backup support for each other. From those data centers, we have local caching offices across the globe. So the concept is I take the information from the data center to my caching office, and my caching office to my computer, and I'm always working locally on my C drive, and I have that portability with my laptop or my iPad to get out into site. We then extend ProjectWise through what's called our gateway to the internet, and we can then connect our ProjectWise to the ProjectWise of other external entities in a joint venture or a prime consultant, sub-consultant arrangement, or we can extend our ProjectWise to any user with an internet connection and a secured login. So when we say put data into the cloud, that is our cloud, but it's a secured, internally hosted cloud today that allows us to really extend our infrastructure to anybody we're working with. Now, there's some complexities with that, and a lot of that is due to your victim of your network connectivity. And we'll show that in the next slide here. So assuming that I have this project BIM, for example, so let's use a Revit example here. We have a Revit central model, and let's say it's just one model. So we have all disciplines feeding this one model. We come upon this issue here where I can use ProjectWise to globally deploy the central model, facilitate local caching, delta file transferring, manage who's checking out and locking work sets or components, element borrowing. It's all great, but that blue one, which is Project Manager, that could be you. If I have slow connection speeds, let's say from India to Denver or from the Middle East to Denver, that's going to be a struggle in order to continually be working. Every time you touch a component, it pauses. Similar situation with Integraph's Plant Suite, Smart Plant. It's based on a central SQL database that we have to put somewhere. So if the project is in Abu Dhabi and you're working from India, you're a victim of your network speed to that connectivity. Or India to Denver, India to Buenos Aires. It could be a challenge. So the concept of the federated database means everything can come together, but it's like sending puzzle pieces across the globe. So you're still victim of your network in order to get your information. But once you get the information to your computer, you're working live. And then that's one benefit that we've harnessed through ProjectWise is this concept of delta file transfer. So I work live on my computer. I'm only sending changes back to the other people. And if I'm the architect and trying to get information from structural, if they make changes, I am only pulling the changes. So even though there could be slow network speeds, we're able to harness and share information to and from users across the globe. It's worked well, and we continually work to try to improve it. My vision is to achieve this. So I was asked maybe 5 years ago, hey, Brent, if we have a $5 billion design project, how are we going to do that? And the issue is, from that first slide where I said we have Autodesk, Bentley, and Integraph products all stewarded within CH2M Hill. Well, on a $5 billion project, I'm going to have users all across the globe. I'm assuming internal, maybe external as well. We're all going to be feeding a project, and we're all going to be using different tools. So then I stand back and say, okay, we're going to have building and civil and plant-based components being fed by various tools depending on what the right BIM recipe is. At the end of the day, if all the asset data definitions are correct, I could be doing a model in Bentley's EcoSim. You can be doing it in Autodesk Revit. Somebody else can be doing it in Graphisoft ArchiCAD. As long as all of the information is common, our client can take the door schedule, the wall schedule, all of the component quantities, and everything will be common. It's a great vision. We're making heavy strides to achieve there. The closest CH2M Hill has come today is with our plant design, where we have piping specs from our procurement system that we can use to feed Smart Plant, Auto Plant, Open Plant, Plant Space, and CADWorks. So 5 different tools from 2 different vendors, all fed from the same piping spec, thus achieving a common data definition for pipes and valves today. So this concept of model synergy, I always want to break up the information models between building, civil, and plant, because each of these tools have unique modeling, analytical, and data exchange type formats. And I won't go through all of these, but why I like to bring this up is because we have some clients who will say to us, you know, Autodesk came over and said, Revit is a BIM tool, so we want to do everything in Revit. And then we'll look at that and say, Revit doesn't do civil. And then we'll say, Revit has a piping module, but it doesn't do piping. It doesn't do plant. And there's a critical difference there. If you look at the plant tools, those are the 5 tools that are kind of active in the industry today that we steward internally. And they all have the ability to leverage our piping specs, generate isometrics, generate pipe stress analysis, or export to pipe stress analytical tools, whereas the building and civil tools don't do that. So you've got to understand that uniqueness. As you're building your BIM recipe, I always challenge our project managers, our project BIM leads, to understand the difference between building, civil, and plant, to make sure that the client is aware of it. They don't have to fully understand, but they need to be aware that you can't prescribe building tools for plant. You can't just prescribe civil tools to make buildings. And understand that difference so that you can have a happy recipe. It may not be the most efficient recipe, but it has to be a working recipe. And then we'll take whatever that solution is, package it around a platform. So this is your CAD standards, your CAD platform, your common data environment for sharing files, anything for program delivery. Deliver that all. Understand what the owner's requirements are. Is our owner can you do BIM and give me a model? And you ask, well, what do you want? And they say, I don't know, just something to drive through. Or is our owner I know you do BIM and I need stuff in my asset management system? Are there other repositories like a geographic information system turnover? The UK requires that quite a bit, as do several jurisdictions within the United States. And then understand how we're getting our information from the recipe to the output, and that finishes the entire program for the project. It's a very critical procedure that we have to go through, and sometimes it's a scaled-down procedure where we just use a packaged solution or an already proven recipe that we can just say, this is what we're going to do, and we apply it. Other times it's quite complex to understand what you have to do and why you have to do it. And lastly, just to touch a bit upon asset management. This was the project we won a Bentley Award for innovation in water and wastewater in 2013. It was a wastewater treatment plant in Las Vegas, so great city to have a project like this. The critical piece of this was the use of the I model, as Malcolm described, the information model generated from the Bentley authoring tools, encapsulating the geometry and the associated information, and we embedded those as the deliverable. So the client asked us, come and BIM my plant, and plus there was a little add-on that we had to design and construct. So the concept of taking, was it about 60 years, hundreds upon thousands of drawings, updated haphazardly over that time. We said, we're going to go in there, model this thing, and then we took the I model and embedded the I model within a PDF, within the frame, and delivered those as the deliverables. So instead of just regurgitating, really, all of the plans and sections, the I model itself, it's an interactive deliverable. You could still print it if you wanted to, but the intent is it gives you your view upon opening, and you can actually manipulate and move around the model within the confines of your PDF. We then had to link existing assets to their asset management system. So while on site, while we were modeling the assets of importance again, so you notice the concrete wall in the background, that was just a concrete wall that was going to last a very long time, so it wasn't important. But the pumps, each one of the pumps, when we modeled them, we gave them the right tag associated to each pump as identified on the existing process and instrumentation diagrams. And then each of the components as modeled were given a hyperlink to a target defined by the client. So the client wanted these pumps to hyperlink to the operational system that was already in existence. So you can look at a 3D model, find a pump, and automatically hyperlink to what the pump, to the control of the pump. And on the control screen, you can see what the pumps are controlling. So those 3 pumps were controlling the 3 centrifuges. And those 3 centrifuges had various off and on options that you can identify. So then they said, well, now that I know those pumps control the centrifuges, I want to know where those centrifuges are. So we made a link from the operational screen into the O&M manual, the operation and maintenance manual, to the information not only about the centrifuge, but also, again, embedded I models about those centrifuges, where you can then manipulate, move around, find another asset of importance, and review the cycle all over again. So that was their definition of how they wanted the model to interact with asset management, and building that recipe was unique. And it was just a challenge, but it was one that obviously we worked to overcome. Now, the message is that CH2M Hill, we're in it together with everybody in this room, with everybody we're partnered with all of our software vendors, to really achieve these BIM possibilities. Understand BIM as a cookbook, understand the numerous recipes that can be out there, build and reuse recipes where appropriate, tweak recipes to meet project or client needs. A solid common data environment is imperative. I can't stress that enough. And it's got to be able to handle program and project delivery throughout the life cycle, not just I made my design model and now I'm good. It's got to be the whole encompassing process that handles the life cycle. And then looking to the future, we presented this in the UK with the Environment Agency. There's a lot of impressive stuff that's coming down the way. Construction work packaging, for example, is a huge piece with respect to understanding and visualizing not only against a timeline, but a timeline with respect to the delivery of packages and the isolating of parts of components and how they will be assembled and delivered on site. Field data collection, paperless job sites are something that we're heavily working on as we speak in order just to remove that concept of print, lose information as described previously. And then from a visualization perspective, there's the holographic imagery, augmented reality are some of the things that clients are getting really excited about. You can Google any of this stuff and just see what's out there, and they want to bring that technology to our models as well. That's it.